In today's lesson, we'll be learning about the sine and cosine ratios. In a previous lesson, we learned that SOHCAHTOA was a mnemonic that helped us remember the three main trigonometric ratios. SO has the letters S, O, and H. S stands for sine theta, O stands for opposite, and H stands for hypotenuse. Ka contains the letters C, A, and H. C stands for cos theta, A stands for adjacent, and H stands for hypotenuse. And you already know what TOA stands for. That's tan theta equals opposite over adjacent. It is important to remember that SOHCAHTOA only works for right angle triangles. Hypotenuse is in a fixed position, so it is located across the 90-degree angle. However, the terms opposite and adjacent are relative terms, so it depends where theta is located, where the angle is. So if I'm looking at this angle, that would mean that would be the adjacent side, and this would be the opposite side. However, if I was talking about this angle, that means this would be the adjacent side, and this would be the opposite side. So the terms opposite and adjacent are relative terms. While the hypotenuse is always in a fixed position, it is located across the 90-degree angle. In our first example, we want to calculate sine t in each triangle, then we want to find angle t to the nearest degree. Our first step should be to draw a diagram. If a diagram is already provided, all you need to do is label it. So all we need to do is find angle t, which is right over here, and I'm going to label it theta, which makes 11 meters the hypotenuse. Since it is across the 90-degree angle, it would make this side the adjacent side, and it would make the side that is 5 meters the opposite side. Now that we've labeled our diagram, we can start with our equation, our ratio, which is sine theta is equal to opposite over hypotenuse. At this point, we can substitute in our known values. I know that the opposite side is 5 meters, and I know that the hypotenuse is 11 meters. Now, we want to isolate the angle. We want to isolate theta. However, it is stuck with this sine. Now, to get rid of it, you have to do the inverse function. Remember, doing the inverse function is not division. It is something entirely different. So, you need to go sine inverse of 5 over 11. And remember, you do need a scientific calculator to do this. And that turns out to be approximately 27 degrees. Therefore, angle t to the nearest degree is 27 degrees. And you'll notice that I've called it theta. You can call it t if you want. It doesn't really matter. In our second example, we want to calculate sine t in each triangle. Then we want to find angle t to the nearest degree. So that means we are looking for this angle over here, and I'm going to call it theta. Now let's start labeling our diagram since it's already provided. Well, this would be the opposite side relative to theta. This would be the adjacent side relative to theta. And this would be the hypotenuse since it is across the 90-degree angle. At this point, we would need to decide what ratio we're going to be using. As you can see, I'm only given the side lengths of the adjacent and hypotenuse. Therefore, I cannot use the sine ratio. I'm going to have to use the cosine ratio, which is cos theta is equal to adjacent over hypotenuse. Now, some of you might be asking me, why can't I use the other trigonometric ratios? Why can't I use the sine ratio or the tangent ratio? Well, you could. You just need to figure out those other pieces of information, either by figuring out the angles or by using the Pythagorean theorem. Anyways, at this point, I'm going to substitute in my known values. I know that the adjacent side is 1 centimeter, and I know the hypotenuse is 2 centimeters. So I want to isolate the angle, I want to isolate theta, therefore I'm going to have to do the inverse function of cosine. And again, you're going to do that on your calculator. And if you do the inverse cosine of 1 over 2, you should get 60 degrees. Therefore, angle t to the nearest degree is 60 degrees. In our last example, we want to solve each triangle, which means we want to figure out the side lengths as well as the interior angles. Let's begin with the simplest thing. Let's figure out the angle of BAC. So we know that the interior angles of a triangle add up to 180 degrees. So let's represent that mathematically. So I'm going to write angle BAC plus angle ACB plus angle CBA is equal to 180 degrees. At this point, you just need to substitute in your known values. Since I do not know what angle BAC is, I'm going to leave it alone. Angle ACB is 38 degrees, and angle CBA is 90 degrees, as indicated by the little square. At this point, you want to isolate angle BAC, and you can do that by doing the opposite operation of plus 38 and plus 90 to the other side of the equation, which means we're going to subtract 38 and subtract 90 from both sides of the equation. So I'm going to skip some of those steps, and I'm just going to write angle BAC is equal to 180 degrees, subtract 38 degrees, subtract 90 degrees, and that simplifies to 52 degrees. Therefore, we've just figured out our angle of BAC. All we need to do now is figure out the remaining side lengths. So let's take a look at what information we have currently. Well, I have an angle 38 degrees over here. This would be the hypotenuse relative to that angle. This would be the adjacent side relative to that angle, and this would be the opposite side relative to that angle. Let's try and figure out the hypotenuse using the sine ratio. So I'm going to write down sine theta is equal to opposite over hypotenuse. So I know the angle is 38 degrees. I know the opposite side is 12 centimeters, and I don't know the hypotenuse. So I'm going to call this hypotenuse, or you can call it AC. I'm just going to leave it as hypotenuse. At this point, you want to isolate your hypotenuse. There are many different ways of doing this. Some of you may be able to do it in your head. However, I'm going to show you the long way. Sine 38 degrees is really the same thing over 1. You can do a cross multiply. So that would give me the hypotenuse multiplied by sine 38 degrees, which is equal to 12 multiplied by 1. Okay. Now, obviously, to isolate the hypotenuse, you'd have to divide both sides by sine 38. So that's going to cancel out, and you get your hypotenuse, which is equal to 12 over sine of 38 degrees. Once you punch that into your calculator, you should get a hypotenuse value of around 19.5 centimeters. Now, all you need to figure out is the adjacent side. You can use another trigonometric ratio, or you could just use Pythagorean theorem. It's up to you. I'm going to use the Pythagorean theorem, so let's set up our equation over here. I have ab squared plus bc squared will give me ac squared. You want to substitute in your known values, so the 12 goes here in brackets. You know what the hypotenuse is. It is 19.5 approximately. You can always carry an extra decimal place if you want a more accurate answer. So let's simplify this. This should be 144. That's going to stay the same. 19.5 squared is 380.25. At this point, you want to isolate BC, and you can do that by subtracting 144 from both sides of the equation. I'm only going to show you a little bit of those steps. So let's go ahead and simplify that. 380.25 subtract 144 is 236.25. Now we want to get rid of the square, so we need a square root both sides of the equation, and that will give us approximately 15.4 centimeters. So what we've just done was we figured out each side length as well as each angle, and I'm just going to circle those pieces of information. It is important to remember that this question can be done in many different ways. I've just done one of them. You might do it a different way, and your friend might do it a different way.